Look at another question. If 5 centimeter cube of 0.2 mol per dm cube solution of sodium trisulcarbonate 4 was diluted with distilled water to obtain 250 centimeter cube solution, what would be the concentration of the resulting solution? Okay, so let's see what we are given. We are given initial volume of the sodium trisulcarbonate 4. Initial volume. Once you see cm cube, it's a volume. So that's initial volume. We can call it V1. Then we have, when you see mole per dm cube, it's a molar concentration. So we call this one initial concentration solution. C1, we call it C subscript 1, 0.2 molar. Mole per dm cube can be written as molar. This capital letter M is molar. Then was diluted. So this is a dilution question. No diluting, adding water so that to increase its volume and at the same time to decrease the concentration. All right, so it's was diluted. The substance was diluted. Okay, so it's a dilution. No, when you dilute, it increases the volume, but decreases the concentration of whatever you are diluting. Okay, there are some people dilute their Coke, their soft drink. Some dilute their wine. Some dilute their whatever, maybe their breakfast. Could be diluting maybe your corn cereal, whatever. So we have a final volume. The question says, what will be the concentration of the resulting solution? So here it was diluted with distilled water to obtain 250 centimeter cube solution. So it moved from 5 to 250. So that's the final volume, 250. We call it V2, 250 centimeter cube. So I'm looking for the final concentration now. Okay, so we have final volume of sodium trisulcarbonate solution is V2, 250. So when it's diluted, it increases when you dilute a substance, it increases its volume. That means the volume increases. So from 5 to 250. So this is initial volume, final volume. Initial concentration, we're looking for the final concentration. So that final concentration, we can call it C2. So our dilution formula says initial concentration times initial volume remain constant. So C1V1 is equals to, that's the product of initial concentration and initial volume remains, the product of C and V remains constant. C1V1 is equals to C2V2 and so on and so forth. So slot that in those values in, make C2 stand alone, and then you have your final concentration.